Hello, folks. Today we're going to be going over the 25s. If you missed class, it is the pre-lab for what we're going to do in our next class. We'll skip over this part right here. So it says many ionic compounds are hydrated. This means that they have water attached to them to the rest of the molecule. On the other hand, anhydrous is a name given to compounds that have no water attached. Formulas for hydrated compounds show water as a kind of addition to the main formula of the compound. For example, iron 3 chloride hexahydrate has 6 waters attached to it in its hydrated state, and the formula is written as you see on your screen. Anhydrous is basically the compound with no water attached to it whatsoever. So again, this is a pre-lab for our lab in our next class. So this is on your sheet. We've done something similar to this already. In class, we calculated molar mass. All right, so here is our formula right here. And so we have one of these irons. This we get right off the periodic table. This is the mass of our iron. We have 3 chlorines. This is the mass you get off the periodic table. This is the total mass of our chlorines. And then we calculate our water separate. We have 6 waters right there at 18 apiece, and we get 108.00. Those are all correct sig figs, all going to the hundredths place. So we're being asked to calculate the percent water. So we put the part that we want to know about, the grams of water over the total. That is 5 sig figs divided by 5 sig figs. And if we do that math, we get 39.970% water, which we put right up there. Then we're going to do the next one on your sheet. I would encourage you to give it a try. Just pause the video and give it a try and see what you can come up with. Then restart the video when you need to. This is a trihydrate, which means there's 3 waters. So 3 times 18 is 54.00 grams. You add all of these numbers together and you get 216.20 grams. Again, part divided by total, so 54.00 grams of water over 216.20 grams. You do that math and you get 24.98%. This is 4 sig figs. This is 5 sig figs. We don't count this one for sig figs, so our answer can only have 4 sig figs. And we write that number up here. All right, so this is a simple experiment that a student did. And it says, in a simple experiment, 2 chemistry students took 3.68 grams of hydrated iron 3 chloride and heated it with a Bunsen burner. After cooling the beaker and subtracting out the weight of the beaker, there was only 2.21 grams of substance left. Fill in the blanks and calculate the percent water. So I encourage you to pause the video and take the 3 or 4 minutes and see what you can do with this problem. Well, I'm hoping that you did pause the video. Our first one is mass of the hydrate. Well, that's that right there. So 3.78. Mass of the anhydrous residue. Well, they heated it up, and this is what was left in the beaker. So the water left the beaker. So this is the mass of the anhydrous. So what is the mass of the water? Well, 3.68 minus 2.21. This is the stuff with the water in it. This is the stuff with the water gone. So the difference between those two would be the mass of the actual water, which is 1.47 grams. Percent water. Well, you take the grams of water, the part you want to know about, divide it by the total. The total is the substance with the water in it, 3.68 times 100. We should have 3 sig figs in our answer. And when you do that, you get 39.9%. So now you go to the work that we did on the previous 2 slides, and one of those 2 had a number that was close to 39.9%. and that was the one with the 6 waters in it. So it's very similar to what we're going to do in the lab. We're going to do the experiment. We're going to calculate the grams of water. We're going to calculate the percent water. We're going to match it up to a table, and then we're going to find out how many water molecules are in the compound. So this is the table. When we do the lab on Monday, everyone is going to do magnesium sulfate. The goal is to find the grams of water in the hydrated compound, then find the percent in the compound, water in the compound, then use a data table to figure out how many water molecules are actually attached to the magnesium sulfate. So this is the table that you have to have filled out for the next lab. It must be 100% done. So we're all doing magnesium sulfate. We don't know how many water molecules are there, so we're going to fill out a table as if it's all the water molecules, so we have all the data. Anhydrous means no water, so that's just simply MgSO4. There's 0 water molecules there, so 0 times 18 is 0. Magnesium sulfate by itself, or anhydrous magnesium sulfate, has a molar mass of 120.36 grams. Part divided by total, there's 0% water in that compound. Monohydrate, the formula would be MgSO4. So there's 1 water molecule there. So that's 18 grams of water. So I basically have to add 18.00 to 120.36 to figure out how much it would weigh, and that would be 138.36 grams. Part divided by total, so that would be your 18.00 divided by 138.36 times 100, and if you do all that, you get 13.01%. I'll do one more with you, and then the rest of the table is for you to do. So MgSO4, there's 2 waters there, 18.00, that equals 36.00 grams of water. Again, add another 18 to this, because we're just keep adding water to it. So that's 156.36 grams. That's the total mass. Part divided by total, so 36.00 divided by 156.36 times 100, and that one would be 23.02%. So the rest of this you have to fill out on your own. When we do the lab, you'll match up one of these percents, and that'll help you figure out what is the formula of the compound. This entire sheet must be done before you come to lab, the next lab, otherwise you'll lose substantial points. So it says in the next class period, your goal will be to correctly determine the number of water molecules attached to the hydrated compound that you're given. Make a materials list, write a simple numbered procedure to accomplish your goal. When you're finished with your materials list and procedure, get your teacher to stamp it at the beginning of class. So we're all going to be using magnesium sulfate. That is it, and dot question mark H2O. We don't know what it is. What are we going to use for supplies? We're going to use a ring stand, a ring, burner. What else are we going to use? A triangle. You'll know that when you show up to class. A gauze pad. Beaker tongs. So that means we got to use a beaker. Matches. I think that's about it. So now we got to write a procedure here, and that means step 1, do this, step 2, do this, step 3, do this, and so forth. So I'll kind of draw out for you what we're going to do. So we're going to have a ring stand. This is our ring stand. It's going to have a ring on it. This is where we're going to place our beaker. We're going to put our burner down below it. and that's going to heat that up, which is going to drive off the water. So what we're going to do is we're going to get about 1.5 grams of the magnesium sulfate. We're going to have to know that mass. We're going to have to know the mass of this beaker. Probably going to need to know the mass of this and the compound together. We're going to heat it for 7 minutes. That should drive off all the water. We're going to let it cool for 7 minutes. Then we're going to weigh it out, and the difference between what we started with, the start weight, which has the water in it, and the finish weight, which should have the water gone from it, that's the difference in those two are going to tell us how many grams of water, which then will calculate the percent water, and then we'll match up to that table on the previous page. That's it, folks. That is the lab. See you tomorrow.